Hello. In this video, we're going to look at 1B for exam 3's review. So here, f of x equals x plus 3 all over x plus 2. We want to find the critical numbers first, which means we need to find the domain. Now, the domain for this function, because this is a rational function, is wherever the denominator, x plus 2, is not equal to 0. Now, if you solve that, that gives you x is not equal to negative 2. So x cannot be negative 2 for this function. Now that you know that, we can go ahead and find any critical numbers. Now, the critical numbers occur wherever the derivative is either equal to 0 or undefined. So we need to go ahead and find the derivative, which means we need to use the quotient rule. So that would be the bottom x plus 2 times the derivative of the top, which is 1, minus the top x plus 3 times the derivative of the bottom, which is 1. And then all over the bottom squared. Good. Now, if we simplify this, distribute the 1, distribute the 1, distribute the negative, that's going to give me x plus 2 minus x minus 3 all over x plus 2 squared. Awesome. Now, the two x's cancel, and 2 minus 3 is negative 1. So that's negative 1 over x plus 2 squared. There you go. That is the derivative. Now we're going to use this to find any critical numbers that may exist here. So the critical numbers occur wherever the numerator is equal to 0 or the denominator is equal to 0. Now the numerator does not produce any critical numbers because there is no solution to that. Negative 1 is never equal to 0. The denominator also does not produce a critical number, although we do see x plus 2 equaling 0, which means x equals negative 2. But notice that x equals negative 2 is not in the domain of the function. So therefore, there are no critical numbers. But that does not mean that there are no important numbers. There is an important number of negative 2. These will always be important numbers. It's just that it's not a critical number specifically. Remember, the definition of critical number is that it's wherever the derivative is either equal to 0 or undefined when it's in the domain of the function. But because x equals negative 2 is here, it is an important number. So on B and C here, to find where the function is increasing or decreasing, we need to take negative 2 into account, which means we need test points to the left of negative 2, say negative 3, and to the right of negative 2, say 0. And then go plug those into the derivative. Now, if I plug in negative 3 into here, negative 3 plus 2 is negative 1 squared is positive 1, so it's negative 1 over positive 1, which is 1. Sorry, negative 1. So that's negative, which means the function is going down from left to right there. Plug in 0, that's 4 in the denominator. Negative 1 over 4 is our answer. So that's also going down from left to right. So B is asking, where's the function increasing? It's not increasing ever. It's always decreasing. C is asking, where is this decreasing? So it's decreasing on the interval from negative infinity to negative 3. Sorry, negative 2, my apologies. And then also from negative 2 to infinity. Notice that it's just at negative 2. It's neither increasing nor decreasing because it's not in the domain of the function. So there you go. Those are your other two answers there. Now, just to see what that looks like when you graph it, let's go to the calculator. So if we go to y equals, on y1, we're just going to type in the original function, alpha y equals enter, and then just do x plus 3 over x plus 2. And then press zoom 6 for the standard window, and notice that the function is decreasing in this domain and decreasing in this domain as well. It's just that x equals negative 2 is a vertical asymptote. And there you go. So this is example 1B. Have fun.